Welcome to this course on the basics of Python for advanced healthcare analytics. We've gotten through the introduction of what it is and why you should care about it. You've also got a video of me walking through a Colab workbook that actually gives you code to run and evaluate those sorts of concepts. And now we're moving into what do we do in Python? What are some of the basic functions and things that we use Python for? Shouldn't have used the word functions because that actually has a specific meaning in Python, but we will cover that. Starting with some of what we're going to hit. We're going to hit on connections, getting connected to data. How do we access and bring data to the environment to use? Containers, so things that we put data into. We create variables or lists, dictionaries, or data frames. And then what are the actions that we do to these, to this data? We can perform operations with loops, we can apply functions, we do some vectorized operations, and then we talk about transforming and pivot. All of this at the high level to give you a concept of what this is, give you a visual of what it might look like, and then we'll go to code in order to investigate it, and not just talk about it. So let's start with the connecting to data. Connecting to data is about getting information to the system to work with, into a data frame, or essentially like a table. Python has a lot of libraries that can connect to a lot of different data sources. I'll show an example here where we might be using BigQuery to connect to and pull information from from data we have sitting in Google's BigQuery. You're going to have to do things like define what is the project, what are any sort of like service account information that you might need to use in order to access that. And with different data sources, there's different requirements for this. Now, I could have done a whole class on connecting to different types of data, how to bring in a CSV, how to connect to a SQL database versus Google BigQuery. And in the past, that would have been incredibly relevant. It would have been necessary to learn the nuances of how do I do this, or where to find good content on examples people have shown you. But the world has changed drastically. I produced this short example in Python by using I believe probably Gemini, actually in the BigQuery environment, and just asked it to connect to my BigQuery dataset and show the first 5 rows of this table. And it did it perfectly. So you see that what it does is it creates a client that's going to go against my project. Actually, first it's bringing in a library that it needs, and then we use just a string essentially to define the query, which is select everything from our data set and table, and then we put that into a data frame. Often when you see in example queries df, that means data frame. And that's what happens when you return this information. You see that in the last line there. So this is easier than ever. You don't need to know every last nuance. You need to know how to ask the question. You need to know where to go look for answers, because now they are easier than ever, and examples. And there's even generative AI that can help build exact working code that you need in order to get to the data wherever you have it. So you're only limited by your creativity and your just persistence on making this happen, making it work, and using the tools that are available to do so. So that's the connecting to data, just so you see an example of what that might look like and the prompt of how I got there. Next, let's get oriented a little bit to what I called before containers. So these are different things in Python we use to sort of place data into. So variable is one type of container in which we can define a name for something where we will make it equal to some value or some series of values. The very top row in this example code is an example of a variable. The variable age is going to be set here to the value of 45. From here on after in the code, whenever I use the word age, it will be as if I had just inserted the value 45 into wherever I put that word. So that is the use and example of a variable. The very next one down is an example of a list. It is a ordered collection of items accessed by indexing it, position. So what is position 0 is Alice, position 1 is Bob, position 2 is Carlos. Notice I started with 0. That's just a convention of how Python works. You'll get used to that and you'll learn how to operate with it. But notice that this says it's an ordered collection of items. This could be numbers. It could be a lot of things. It is not just limited to that. Here's an example where it's strings. It could be a list of different variables that we already have described earlier in the code. It could be a list of functions. It could be a list of objects. Many, many other things. It's pretty versatile. Next is a dictionary. Now, a dictionary is slightly different than a list because it has key value pairs of structured data. So this is a pair that you see in the example of gender and then the letter F. And so here in demographics, that is me creating a dictionary as an example where we can go and look up what is the value that we have associated with the key of gender or the key of zip code. So you can imagine this might be storing information from, demographics we took from someone where we gathered their zip code and their gender. We can get the answer by asking a question of this dictionary, like, for this person, what is the value item for the key gender? What is the zip code item for the key zip code? So that's how dictionaries work. Now, functions, we'll see some more examples, but they are reusable actions that take inputs and return outputs. Now, just for again, showing you that you're not alone anymore. This is not that you're limited to how many videos I make or what content I cover. It's all out there, and you can figure out how to do it. It's pretty amazing. This is me just saying, hey, show me some examples of how to do these things in Python. So we'll come back to functions a little bit later, but let's go on and talk about data frames. Data frames are essentially in-memory tables. You can think of it just like your Excel spreadsheet that has a table of information. It is rows and columns, and we can add new information to it. You can use the information that's in the table to calculate new information. You can summarize and explore the data from here. As an example, I got to this by saying, give me the first 5 rows of this data frame that I had already sort of shown. Now, one thing that we do when we have a data frame is when we apply mathematical operations to it, we are typically applying vectorized mathematics, which is kind of like matrix math. If you've ever done some linear algebra work, it is a very efficient way for the computer to be able to do mathematics against a data set. So it is, as an example here, you've got calculating length of stay. It is telling the code to go ahead and take the discharge date time and subtract that from the admission date time. And, you're using a library there, DT, and telling it what you want it in, days. And so this is going to be in a very, very efficient way to compute, as opposed to essentially with loops or other types of processing where you tell for row or record 1, do this action, then move to record 2, then move to record 3. Actually, Python allows us with data frames to do this in a way, way more efficient fashion. Just to give you a little bit of the intuition of the difference, visually, it's kind of the difference between going from a single knife and, processing each cut individually to something where we've defined how this cuts, and we just continue that over and over. Now, I say that it's much more efficient, and you might not have any sense of the magnitude. So this article here is a great one that does a nice, kind of robust look at this question, and then puts it into some basic operations so you can actually see the timing difference. And so in this example, they take 1 million random numbers and then do some compute questions against it, doing some basic math. One they do with just typical data frame math, which would be vectorized, and then the other, they go ahead and do it as a loop so that you can see the difference. And that looped version is where you say, for record 1, do this action, record 2, do this action. And that result had a computational time in milliseconds, so not very long, but you can imagine how this multiplies out to bigger and bigger data sets or more and more complex math. With the looped version, it took this 1256 milliseconds. But the same operation, getting to the exact same end result by doing it vectorized or essentially in a data frame and applying the math that way, it took that 1200 milliseconds down to 4.5. So it's incredibly more efficient for your computer to be able to process this information and apply mathematics to it. Another thing that we can do with Python is to summarize data and group and transform it, even pivot it. So as an example, we've got this DRG counts here, which we are making by taking our data frame and asking, going to this hospital DRG name column, and then we apply this function value counts. It is really simple, and it's this great capability that that our libraries afford us by having these sort of functions there and baked in to it. This is part of the pandas libraries, and so this value counts can help us to produce something like the image on the right that shows for each one of these DRGs how many of them did we have. And so this is a pretty quick and simple way to aggregate and calculate over potentially a very large data set. In this case, not so much, not huge, but showcases what you can do in some of those aggregating type questions. Below that's an example of pivoting that information. So we could go ahead and take our data frame and pivot it. You can see that we're doing it by the hospital DRG name, and then we want to look at the hospital origin group and then do a count of the CSNs. And so you're going to get, as you can imagine, a pivot of the information that summarizes by DRG and by origin group what is the count of hospital CSN. So now that may seem trivial because it would be something you could easily do in pivot tables, or you could easily do by copying and pasting the data or using some aggregate functions in Excel. But this sort of compute really scales. So this allows you to do the same kind of question across millions or billions of records. Again, this may look like, oh my gosh, this is hard, this is cryptic, difficult information. I would completely disagree. The world has gone upside down, and this becomes so easy to do. You just need the intuition and understanding that you need to pivot and understand your data in some certain way, and then ask for it. Help me pivot this admissions, so rows are DRGs and columns are origin groups. And there we go. We've gotten to a working pivot of the data with just a suggestion, which is phenomenal and really helps take away a lot of the headache, long months and months of learning these programs before you have any efficiency or effectiveness. You can start thinking with data so much quicker than you could before. Before you had to spend a really long time learning this specific coding language in order to be able to accomplish anything meaningful, and that is not the case anymore. You can accomplish meaningful computation quickly and continue to think through your problem and think through deeper different parts of your problem, which is really exciting. So now let's talk about a loop. A loop is doing anything repeatedly, doing something repeatedly here. And so loops help us to take a task and apply it many times without rewriting the code. So think of it like, telling the computer, do this on every patient, do this in every one of these situations. Saves time and avoids mistakes, makes things scalable. So you're seeing a very simple loop here in an example with a printout, so you can get the intuition of how this would work. You're going to see that we have patients in a list, and then after that we have a loop where we ask for every patient P in patients. We print out hello, and then that patient item from the list. So that is how we can iterate over something or loop over something like a list and do something specific with each element of the list. So that's an example of a loop and something that comes in handy within Python. Finally, functions. I mentioned before we would get to functions, and here it is. Functions are like a recipe, that you've designed. What are the steps that I want to happen, and what are the ingredients or the information I need to pass in order to accomplish that? And so you're seeing a simple example here where we call this calc LOS, or calculate length of stay, and it's going to need two things in order to do this: admits and discharges. And this would allow us to go ahead and put in an admission that we may have and a discharge into this and get back that answer. Now, this is doing something very simple, so it seems like it's unnecessary, and it is. That's the truth. This would not be a type of function that we would write, but you're going to see plenty of examples of functions later in my code and or through other content. So I just want you to see the basics of what we're talking about. We're talking about that def word just means that we are defining a function here. And then we give it a name, calc LOS. We say what is going to be given, admits and discharges, and then we do something with what's given. We run a mathematical equation so that whenever you pass information into it with those two items, admit and discharge, you will get back an answer. So that's an example there of a function, like a reusable sort of building block in your code. So that's what I wanted you to see on the basics of what Python is. First, connections, the ability to connect out and bring data in and then contain it within a list or variables, maybe a dictionary or a data frame. Most commonly, we're working in data frames in healthcare analytics. And then the actions you can take on top of that data, like put it through a loop to apply something over and over, perform functions on it to do vectorized operations quickly, and then we can also transform and pivot our data. So those are the basics of where and how we're using Python in healthcare analytics.